The last kind of questions we're going to look at in this section are those that involve using the calculator in order to solve the equation. In example 11, they want us to solve each equation correct to 4 decimal places for x ranging between 0 and 2 pi. The first one is the tangent of x equals 12.8044. And again, if you look at kind of the range we're looking for, these are obviously going to be angles that are in radian mode, so make sure your calculator is in radian mode. If we want to solve this equation kind of classically to get the x by itself, we would need to remove or get rid of the tangent function, which means we would need to apply tangent inverse to both sides. On the left-hand side, tangent inverse and tangent are inverses of each other, so their composition just produces the value x. And then in your calculator, you would do second tangent inverse of 12.8044. And they ask us to round this, I believe, to 4 decimal places. To 4 places, you should get an answer of 1.4929. So certainly this is going to be one solution. There's actually another solution, and we have to kind of think a little critically about this. If you remember how tangent inverse works, okay? So when we apply the tangent inverse, we said that the range of tangent inverse was angles between negative pi over 2 and pi over 2. Because the tangent was positive, this angle that was given to us, this 1.4929, this was an angle in quadrant 1. If we think about going once around the unit circle from 0 to 2 pi, the tangent, however, is also going to be positive in quadrant 3. Furthermore, the tangent is also periodic with period pi. So in order to find that third quadrant solution, all you would need to do is take this first quadrant solution and simply add pi to it. So if we take our 1.4929, add pi to it, we would get 4.6345. So the tangent of x equals 12.8044 has two solutions between 0 and 2 pi. Those solutions are 1.4929 and 4.6345. Let's take a look at the next one. We're asked to solve the cosine of x equals negative 0.4317. So again, to get the cosine by itself, this isn't a ratio we would have memorized, but to isolate the x, we can simply apply cosine inverse to both sides. Cosine inverse and cosine are inverses, so they cancel. We get x equals inverse cosine of negative 0.4317. And we get x equals 2.0172. So this is going to be one solution, but there's another one out there as well. Remember, whenever we apply cosine inverse, the range of cosine inverse is from 0 to pi. Furthermore, notice that we were looking for where a cosine of an angle would be negative. That angle that was given to us, that x value, is from quadrant 2. However, we also know if you look from 0 to 2 pi, that the cosine is also going to be negative in quadrant 3. All students take calculus. So there should also be a third quadrant solution as well. In order to find that third quadrant solution, let's do the following. I can find the first quadrant acute reference angle that corresponds to the solution that we just found. So remember, if your angle is in quadrant 2, the reference angle theta prime would have been equal to pi minus theta. If we solve this for theta, that means that theta would be equal to pi minus theta prime. Oops, excuse me, we don't need to solve for that. Just actually plug it in directly there. Theta prime is going to be equal to pi minus 2.0172. We'll round this to 2 places, or excuse me, 4 places. And we would get 1.1244. This would be the angle in quadrant 1, whose cosine would have the value positive 0.4317. We now need to find what angle in quadrant 3 would have this value as its reference angle. In quadrant 3, the reference angle theta prime was found by doing theta minus pi. If you want to get theta by itself, you just add pi to both sides, and we find that theta is going to be theta prime plus pi. So the other solution, the other x value that would work, is going to be 1.1244 plus pi, which is about 4.26, and it's going to double round to 60. The 9 would bump a 9 up to a 10, and the 10 would bump the 5 up to a 6. So this equation also has 2 solutions between 0 and 2 pi. Those solutions are 2.017